So welcome to this video, and in today's video we will be going over 1.4, which is all about negative and fractional indices. So let's go. Okay, so these are the 4 rules which we need to know for this chapter. So the first rule I'll go over, that is a to the power of 1 over m is equal to the m root of a. We have a to the power of n over m, that's equal to the m root of a to the power of n. We have a to the negative m, that is equal to 1 over a to the power of m. And then we have a to the power of 0 is equal to 1. Okay, so those are some of the rules we need to know. And I'll go through some examples of what that looks like. For example, if I go through some examples next to it, if we have something like, let's say we have a to the power of 1 over 4, then that is the same as saying, like the fourth root of a, for example. Equally, we could have something a bit more simple. Let's say we just have like a to the power of a negative half. That is the same as saying the square root of a. Note that I don't put the 2. I can put the 2 here if you want, but remember that the square root it's implied that it's going to be 2 there, so you don't need to put it down. But effectively, that is what that rule is, okay? So if you see anything where it's a number to the power of a half, that means that it's the square root. You can also have another one too. Let's say we have a to the power of, let's say 3 over 2. Then that is the same as saying 2 to the a to the 3 as well. So you can say it like that too. And then this one over here, if we had a to the negative 4, then that is the same as saying 1 over a to the 4. And then obviously a to the power of 0, anything to the power of 0 will always equal 1. Okay? So let's get on to some examples. Okay, so our first question we'll go over is this one, 9 to the power of a half. So as we learn from those rules, 9 to the power of a half is the same as saying the square root of 9, and the square root of 9 we know is simply just 3. Okay, let's go over another question. Let's go over 49 to the power of 3 over 2. Okay, so the same thing here. Going back over your rules, what we can do, there are loads of ways we can do this. The easiest way would be that it's the square root of 49 to the power of 3. And we know what the square root of 49 is. We know the square root of 49 is 7. And then that is to the power of 3, which if you used to work out, you would get 243. So with this question, we have 25 to the power of minus 3 over 2. So first things first, loads of ways you can do it. What I would do is get rid of the negative now. To get rid of the negative, that would be 1 over 25 to the 3 over 2. Okay, and then once you get to that stage, well, we have 1 over the square root of 25, and that is raised to the power of 3. So you work out the square root of 25 is just 5, and then we still have that to the power of 3, and then 5 to the power of 3 is simply 125, okay? Okay, so let's go over this question here. We have the square root of x, and that is times by the cube root of x. So how do we work this out? What I would do here is I would rewrite both of these values as a fractional indice. So we know that the square root of x as a fractional indice is x to the power of half. And then we know that with this question here, okay, with the cube root of x, which would mean that this would be to the power of a third, okay? You don't need to do this, but I think this is a lot easier to explain. And once we get this stage, now we have x to the power of a half, and that is times by x to the power of a third. And then we know that when we have questions like this, we learned this in our previous indice lesson, a few lessons ago, that is the same as saying x, a half, plus a third, okay? And if you used to work that out, you would get x to the power of 5 over 6, okay? Okay, so for this question, we have the square of x, and that is all cube rooted, and then we also have the cube root of x, and that is all raised to the power of 4. So again, for this question, what I would do is I would rewrite the root as fractional indices. So if we do that, we get x to the power of a half, and that is all raised to the power of 3 times by x to the power of a third, and that is all raised by to the power of 4. And now when we have indices like this, we can just times them together. So we'll do a half times 3, which is, so that'll give us x is equal to, x to the power of 3 over 2, and that is times by x, and then we have 1 over 3 times 4, which is 4 over 3. So now we have x to the power of 3 over 2 times x to the power of 4 over 3. And now when we have this question here, that would be x 3 over 2 plus 4 over 3. And if we were to work that out, we would get x, and then 3 over 2 plus 4 over 3. If you're unsure, then just work it out. So if we make both over 6, then we'll get 9 over 6, okay? And we get 9 over 6 plus 8 over 6, and then that would equal x to the power of 17. Oh, that's a bad 17. Let's do that again. 17 over 6, okay? Okay, with this question here, we have 27 over 8 to the power of 2 over 3. So what we can do with this question is, we can actually cube root everything. So cube root of 27 over 8, and then we can square. So if we do this, then 4. If we cube root 27 over 8, then that is the same as saying the cube root of 27 divided by the cube root of 8, okay? And if you were to work that out, the cube root of 27 is 3. The cube root of 8 is 2. And then that is all being squared. And now it's very simple to work this out. It's the same as saying 3 over 2 times 3 over 2, and that gives us 9 over 4. Okay, how about something like this? We have 5x to the power of 3 minus 2x squared, all divided by x to the power of 5, and we need to simplify this down. So for this type of question, first thing I would do is break up the fraction into two separate fractions. So we get 5x to the power of 3 over x to the 5 minus 2x squared, and that is also divided by x to the 5. And now this looks a bit better. Now we can simplify this down. So if we simplify this down, well, we can't do anything with the 5, but we have x to the 3 divided by x to the 5, which is the same as saying x to the power of 3 minus 5, which would give us a negative 2. And if we go on the other side, we would have a minus 2. Now we have x squared divided by x to the power of 5. So that would be the same as saying x to the power of 2 minus 5, which would give us an x to the negative 3. But we're not done yet. Let's get rid of the negatives. Okay, usually when they want us to simplify it down, usually we don't want to keep any negative indices in there. We want to rewrite that. So if we rewrite this question, we would get 5 over x squared minus 2 over x to the power of 3. Okay, so for this question, we have x times by 2x minus to the power of minus a third, all raised to the power of 4. So for this question, what we got to do is we got to deal with the brackets first. So in this case, what we would do is we leave x on the outside for now. And if we raise all the numbers to the power of 4, it would be 2 to the power of 4 and it will also be times x to the power of 1 over 3 times by 4, okay? If you work that out, you get x still on the outside. 2 to the power of 4 is 16 times by x minus 1 over 3 times 4 is minus 4 over 3. And now at this stage, now we need to multiply this together. So effectively, it would be like saying x to the power of 1, and that is times by 16x to the power of minus 4 over 3. And it's the same way we always do it. That is effectively the same as saying 6x 1. In this case, it will be 1 minus 4 over 3, okay? And if we work that out, we would get 16x. If we rewrite 1 as a fraction, that would be 3 over 3 minus 4 over 3. And then that would give us a 16x to the negative 1 over 3. And then we can rewrite that as 16x to the power of over x to the power of 1 over 3. Okay, so for the next question, we have y is equal to 1 over 8 x to the power of 3. And we want to rewrite that in the form of k times x to the power of n, where k and n are constants, and we want to find the value of y to the power of 1 over 3. So if we know that if we know what y is, and we want to find out what y to the power of 1 over 3, in this case, it would just be 1 over 8 x to the power of 3, all raised to the power of 1 over 3, okay? So if we work this out, then we would do 1 over 8, and that is going to be raised to the power of 1 over 3, and that is x 3, and that is all being times to the power of 3. So that is the same as saying the cube root of 1 over 8, and then we have x, we have 3 times 1 over 3, which is just 1, so we're left with just x. The cube root of 1 over 8 is simply just going to be 1 over 2, and that is times by x. So now we have a half x, and we need to rewrite it in that form, kx to the power of n. Well, in that form, it's actually just the exact same. It would just be, you can leave it as 1 over half, or if you want to, you can write it as 0.5x. Oh, sorry about that. My pen is being a bit weird. You can write it as 0.5x to the power of 1 if you want to. You can even write it as a half x to the power of 1. I'm just putting the 1 here because it says the where k and n are constants. So in the exam, it's always just nice just to really just show them what the constants are. After this question, you can always write something like where k is a half, or where k is 0.5, and when n is 1. Okay, so for the next part of the question, we have the same thing. We have y is equal to 1 over 8 x to the power of 3, but now we have a half y to the power of negative 2. So for this question, what that would look like is we have a half here that is being times by all of y, which is 1 over 8 x to the power of 3, and that is being raised to the negative 2, okay? So we need to deal with our brackets first before we can even think about the half. So what that means is, first things first, we can rewrite this all. So we'll have a half, that will be times by 1 over 8, okay, x to the 3, okay, and that would all be squared, okay. The next part of that is we have a half. We have 1 over 8 squared. 1 over 8 squared, that would be 1 over 8 times 1 over 8, so that's 1 over 64. X to the power of 3 squared, that would be x to the positive 6, okay? And now we're at this stage, so we've got a half times by 1 over 64 x to the 6. It looks a bit weird, but what we can do in this situation is, because we have a 1 divided by a 1 to the 64, that is the same as, we can actually flip the fraction. So what that means is we end up with 64 x to the negative 6. I'm just writing it as a negative 6 just so it's all on one level for now, and I'll move it back later. If I scroll down a bit, now we can we can now times by half. If we times by half, we would get 32x to the negative 6. And if we rewrite that, so now I can move the x back to the bottom, we would get 32 divided by x to the power of 6. But you didn't need to make x a negative. I just did that just to keep everything on the same level, and then I moved it back afterwards. Okay. And that will be it for today. I hope you enjoyed this video and went over the negative and the fractional indices 1.4. The next lesson we'll be going over 1.5, which I believe is third. So stay tuned for that, and I will see you soon.